Alright, number one, find the first four terms of a sequence. If negative 54 is A1, it starts with negative 54, comma, and then this is AN minus 1 plus 7, so you're taking each term, and then just adding 7, so you get negative 47, and then you add 7 again, you get negative 40. Alright, so the only one that matches is A. And that's arithmetic. Okay, adding and subtracting is arithmetic. Don't forget, multiplying and dividing is geometric. Alright. Alright, next one, number 2. One second, of course. Come on. Okay, Joe has $625 in her checking account, but plans to withdraw $78 each month. Now, this has a constant and a changing amount. That is definitely a linear equation. Okay, so the each, that number is the M, and your starting amount, that's your B. Okay, so By equals 78. Negative 78x plus 625, or you can flip that around, 625 minus 78x, which would be letter B. Okay. Another thing you could have done was drawn a little table, and you could have had 0 is 625, and then you just keep subtracting 78. So 625 minus 78. By 47, I think. Out. And then do menu 413. Get the same thing. Something like that. Alright, number 3. Okay, table shows how much remains on our gift card after each purchase. Linear function is typing this into spreadsheet and doing menu 413. So let's remember how to do that. You go into the calculator. Okay, you do new document, don't save. List in spreadsheets, X and Y have to be at the top. Okay, and then our table for number 3 is 0, 1, 2, 3, 4. And then we got 25, 21.93, 17.94, 12.79, and 9. Menu 4, 1, and linear is 3. X for X, Y for Y. I said Y for Y. Alright, so our slope is negative 4.1. Our B is 25.56. Now your answer choices aren't exactly like that, so they probably only put in a couple of points. The closest one with a M of negative 4 point something and a B of 25 would be B. B is the closest. Okay, this is too rounded. Number 4. Okay, which of the following equations? Now, look at all these. These are all these are all x squared, which means quadratic. So that's menu 416. Okay, so menu 416. Another way you can tell is by, if you did linear, your r squared would not be exactly 1, but on this one, your r squared should be exactly 1. So, on your document, don't save the spreadsheets, x and y are always at the top. Now this has 0 through 6, that's a lot, but let's do it. -7, -2, 13, 38. Menu 4, 1, and quadratic is 6. X for x, y for y. Alright, now, go up. A is 5, B, that means 0, C is -7. So we'll have 5x squared minus 7. D. Okay. And notice on here, r squared is 1, so you know it's correct. Alright, number 5. Now this one, there's 2 linear answers and 2 quadratic answers. Let's see what's happening each time. It's adding by 11, then it's adding by 15, then it's adding by 19, then it's adding by 23. So that's not the same, so it's not linear. Let's do the second difference. Well, hey, they're all 4. So what does that mean? Quadratic. Menu 416. So let's do that. X and Y. Quadratic is 6. X for x, y for y. A is 2, B is 5, C is 4. 2, 5, 4. And r squared was 1. Yay. Alright, so it has to be letter D. Alright, now every one of these has x cubed, which is cubic. Let's try it again. X cubed, which is cubic, which is menu 417, I believe. Okay, so let's do this. Nine and 1/3. 9 plus 1/3. 26 plus 2/3. 60. 111 plus 1/3. Alright, so again, cubic is menu 417. X for x, y for y. Enter. So A is 0.3 repeating, D is 6, C is negative 3, D is 6, and then our R squared is 1. Yay! So, basically A is 0.3, 6, negative 3, 6. And R squared equals, yeah. So, which A has 0.3 repeating? Not that, not that, not that. So there you go. And that one does match perfectly, letter A. Alright. Now to determine if they're cubic, linear, x quadratic, etc. Okay. We do differences. Okay, so this one's going down what? Minus 6, minus 6, minus 6, minus 6. That is all the same, so that's linear. Alright. Try this one. Minus 24, minus 16, minus 8, 0. Well, it ain't linear. Try the next one. Minus 8, minus 8, minus 8. Hey, the second difference is the same. That's quadratic. Quadratic. Alright, let's try 10. Okay, what is this? Plus 4, 28, 76, 148. Is it linear? No. Okay, and then this went up what? 24, 48, 72. That's not quadratic. What's next? 24 up to 48 is 24. 48 up to 72 is also 24. The third difference is the same. That's cubic. Woo. Okay, now, besides it being process of elimination, okay, on this one, if you divide negative 25 over 125 is 0.2. Negative 5 over 25 is 0.2. Negative 1 over negative 5 is 0.2. 0.2. So, when you divide, that means it's going to be exponential. Sorry, I missed some of this. On 11, you can see the y-intercept over here, but we graphed it, and we saw that the x-intercept is negative 1.83, which is the same thing as negative 1 5/6 on here and here. The y-intercept, when you go over, is at 0.11. So these are fine. So we notice that this has to be eliminated, this has to be eliminated. However, domain and range is what really we got to know. For linear, it goes forever to the left, forever to the right, forever up, forever down. For a linear function, so that could not be up here, it has to be letter D. On 12, A is a vertical stretch or compress, and it reflects over X. So the only answer that answers A would be B. Okay, down here, that 2 out front is a vertical stretch by a factor of 2. So we eliminated A and B. That -1, remember C is a liar, so instead of being left 1, it's really right 1. So right now it's neck and neck between C and D, but that +5 at the end means not a lie, it's up 5. So that's why the answer was C. 14, we're saying which function has a range like this, from -infinity up to 2. So if it goes from -infinity up to 2, it's going to look just like this. Okay? Now that means it reflected down. That means the A value has to be negative. The number way out front has to be negative. And if it goes up to +2, then your D value has to be 2. So let's look at A, B, C, and D and which one of these matches. Now, by the way, you could graph any of these and see which one gives you a graph going down all the way up to 2. Okay, but I see that A and C are eliminated because this is not negative, this is not negative. And remember, our D value at the very end needs to be +2 because that's how it's been shifted up. That -5 ain't going to fly. It's got to be B. You can graph it and check. Okay. Alright, so if you remember when we did these rational functions, okay? So what is this? This is rational. And rational, if you remember, looked like this. Okay. So this one had the interruption in the domain and range at the C and the D value, okay? Now, if you look right here, C equals 0, there's no parentheses or nothing. If you look right there, D equals -5. So you're going to look for 0 and -5. This, for the domain, it does not touch 0. And then -5 for the range, it does not touch -5. It's going to have those U's when we do that. Okay, so which domain has 0 where, okay, so not that or that, could be A or B. Which domain has -5, not +5, but -5. A does not touch 0, not touch -5. Alright, so again, rational. Okay, so that's my A value. It's a vertical stretch of 7. That's my C value. That means it's a shift left 3. My D value going down 1.5. So vertical stretch by a factor of 7. We're all good here. Translation to the right or left 3. Remember, C is a liar. So +3 means left 3. Left 3, left 3. And then units 1.5 up or down. Well, that says minus. It's not a liar, so it's down, not up. So it's going to be letter C. Alright, X and Y intercepts. We got one intercept right here. When Y is 0, that's my X intercept, 3, 0. X intercept. Hey! That was easy. Now, what can you do? Graph that, menu 5-1 it, and trace. Okay, I'll let you do that, but there's only one answer given that table. Alright, function is given, which of the following best describes the domain and range of the given function. Okay, now, you can graph that in your calculator. Just remember that this is an asymptote. Okay, so for these exponential functions, the domain for exponential, the domain is always negative to positive infinity, for sure. So, eliminate A. Okay, the range on this one goes down forever. So it's negative infinity, up to, and not touching 3. So it'd be 3 with a parentheses. Okay, So it doesn't go up forever, it doesn't go to -3, it goes to +3. Alright, which function has an x-intercept? Okay. So what I want you to do is graph these and just see which one crosses this line, right? So linear functions always have an x-intercept. Okay. A positive exponential function shifted up, nope. A negative quadratic shifted down, nope. A positive absolute value shifted up, nope. There's only one that crosses the x-axis, and linear will always have an x and a y-intercept. Okay. All right, next one, number 20 of 33. Geez. All right. Which of the following is the same for both functions? Okay. Vertical. So the only thing they have in common, we'll be doing in green, is this right here. This horizontal asymptote. They both don't touch at y equals 0. So that horizontal asymptote is the same. Okay, for inverses, if there's an x-intercept of c0, the y-intercept would be 0c. There you go. It's not the x and the x. Nope. And if you have AB, it's not negative B. There's not negatives. It's just BA. That would be the right thing. Okay. So remember, inverse just means switch. Nothing to do with negatives. Switch x and y. All right. All right. For inverses, remember you just flip the table. So now all the answer choices start with -1 and 1. So let's look at for an x value of -1. The y value is -1. -1, not -1. -1, not -1. -1, -1, -1, -1. All right. Next one. Okay, 1, 1, 1, 1. Now wait, that matches the exact same. Needs to flip. Okay, so 0.2, 5, 0.2, and 5, switch. Right, switch x to y. 5, 2, hey, there you go. 1, 1, there you go. Okay, only C flips x and y perfectly. Alright, what restrictions must be true for the two functions to be inverses of each other? Do you see how this one only goes from 0? So, rewrite that. So right here, this is 0, -2. Flip it over, -2, 0. Only this will be reflecting only this. Okay, so what we want to do is cut out this part. So our restriction is going to be starting at this x value, which is -2, inclusive, and it goes to the right forever to infinity. So the domain is from -2 to infinity, from left to right, so domain. Okay. Cube root function, what's the domain? Now remember, cube roots, domain and range are negative to positive infinity for cubing, always. Okay. Don't matter. Yeah, cubic don't matter. So let's just look at the graph on this one. On the graph, we have -4, -4. So for inverse, switch x and y, but it'll happen to be the same thing, letter D. So again, for inverse, make sure you flip them. Okay, we got these functions. The following equation is best described as h of x. Okay, so the inverse of this. Alright, so y'all remember doing this. Get rid of the loaner. Then you log both sides. The log and the 10 cancel out. So I have log 10 x minus 3 equals 2y minus 1. Add 1. And then last step, divide by 2. Now, do I see this thing in the answer choice? I do. Now, I could rewrite it as my final form. Okay. What's the vertical asymptote of its inverse? Well, it's the horizontal asymptote of the regular. So horizontally, it cannot cross this line. So if this horizontal asymptote equals, horizontal asymptote is y equals -2. The vertical asymptote will be x equals -2. The inverse will not cross that line. Okay, so what do? Switch x and y. Same number. What do these all have in common? This one has a point in here, 2, 0, between these numbers because it's linear. So since 2, 0 is across the board, that's the same x-intercept. What can you do with that one? You can do menu 413, graph it, and then Control T to get the table, and you'd see the 2, 0, and then the other ones have 2, 0. Same x-intercept. Alright, which statement describes the domain of fx? So f of x is from here. The domain starts at 1 and goes forever to the right. Okay. And it matches this absolute value function, which is h of x. So it goes from 1 to infinity. It should be c. Down here. Which point is the vertex of the absolute value? Absolute value has vertical lines. Not a radicand? Nope. This has nothing. Nope. It's got to have these vertical lines at 3, 1. Okay. So that's absolute value. Remember, C is a Liar. So negative 3 will become a positive 3, comma, 1. Alright. Are these inverses? Alright, sorry. There's some errors there. Hello? Yeah. Oh my gosh. Alright, sorry. Check this out. On the left side is going up 2. So when x is 0, that's my b. And then my m is my change in y over my change in x. 6 over 2, which is 3. So my equation for that original function is 3x minus 8. So if I switch x and y, get rid of that loner, add 8. X plus 8 equals 3y divided by 3. My inverse function is going to be x plus 8 over 3. Now I can go to my calculator. Alright, I graph that, and I'm looking at my hit Control T for table. Is negative 5, 1 on here. Yep. Is 1, 3 on here. Yep. Is 7, 5 on here. Yep. And is 13, 7 on here. Yep. So, they are inverse. Okay, so you might have to turn a table into an equation, get the inverse, and get the table of that equation. Alright, we need to find the inverse of this one. So it's x equals 64, y plus 2 cubed minus 8. Add 8 to both sides. So x plus 8 equals 64, y plus 2 cubed. Get rid of that 64. Okay, to get rid of that cube, we're going to do a cube root. Now, when I cube root the top, it's just going to be cube root of x plus 8. When I cube root the bottom 64, that's 4 on the bottom. So you're going to get 1/4 out front. Y plus 2, and then I subtract 2 on both sides. So my final form is 1/4 cube root x plus 8, and then minus 2 goes after that. Last one. Which one is not true? Okay, so this is f, this is g. So for f of x's domain is all real numbers. Yes. The range is from 0 to infinity. Yes. For g, the domain is from 0 to infinity with a bracket. No, it has to be a parentheses. It does not touch. F of x, there's no x-intercept. That's f of x. Yeah. For g of x, there's no y-intercept. Yes. Sorry, my bad. Which one is not true? So I have it mixed up. It's going to be B. That's true, that's true, that's true. Alright.